Okay, hello everyone. Thank you for joining the Chicago PowerShell user group this evening for a special online presentation by the well-known and respected Don Jones. Don is a 15-time Microsoft MVP recipient, an instructor, and speaker. Don has written dozens of IT and business related books, self-improvement books, including the first ever published book on Windows PowerShell. He's also the co-founder of PowerShell.org and the PowerShell Summit. And he was named PowerShell First Follower by Jeffrey Snover, the PowerShell inventor. He currently works as a vice president of Pluralsight and has his fingers on the pulse of what's happening in IT. His recent work is called Shell of an Idea. It's a book of the untold history of PowerShell, which you can find on LeanPub. Without further ado, I'll go ahead and hand the mic over to Don.
Cool. Thanks so much. Yeah, so we're gonna just spend a little bit of time talking about some of the cool stories I've kind of uncovered as I was doing research for the book. It's kind of about hidden features, things that are actually in PowerShell that either people don't know about or honestly, in some cases, never played off the way that everybody had hoped it would. Along with some untold ideas, some things that the team had hoped would happen, but would have been cool, but never made it. It's kind of interesting. I think it's fun to see a little bit about the history of the shell. And you kind of get a feel for why things are the way they are as you walk through some of these. So a little bit about me. I've been working with PowerShell since before its launch in 2006. I was able to co-present with Jeffrey Snover on the stage at Microsoft Tech Ed Europe 2006, which is where PowerShell was officially launched to the public. And that is a picture of me on PowerShell's 6th birthday. So I've been playing with this for a while, and it was really kind of a goal of mine to always write. I always wanted to write a history of PowerShell book, and because there's so many good stories. Like, you know, you'll hang out with some of the team on the expo floor of a conference, or maybe at an MVP dinner or something. They've got all these wonderful stories, and I always said I really want to do this, and it took a lot of executives finally leaving Microsoft before everyone was like, yeah, we're comfortable with these stories being told now. So we'll share a little bit of it. Hidden features and untold ideas. We're all used to running pipelines, right? Like everybody knows what a pipeline is, command A, pipe command B, blah, blah, blah. We tend to run these on a single computer. Like you type out your command, you hit enter, that's the computer it runs on. So something like this, get something, pipe to do something, pipe to format list. What's interesting is originally in the concept for PowerShell, they had the idea that some of these commands could actually be on remote computers. And you can do this today, like using implicit remoting, you can bring in a command that's technically running on a remote computer, and you can build a pipeline like this where something in the middle is on a remote computer. But think about what that does to the network for a second. Like if in this example, if get something is producing 10,000 objects, you've got to ship 10,000 objects off to that other computer, and it's got to do something, and then it's got to ship them all back so that your format list command can run. That can get really chatty on the network because every single one of those is going to have a little bit of overhead. So they had this idea of buffering. And this exists, it's in the product today, it's just nobody uses it. It's the out buffer common parameter, and it accepts a number. And all that does is say, look, before you go to ship these things off to the next command, wait until you have 10. You type minus out buffer 10, it'll save up that many and send the commands along in batches so that you're not pounding the network quite so hard. The default is 1, which is the behavior we're used to, everything just gets sent on. What's a really cool story here, though, is Kenneth Hansen, who was the program manager who's kind of running this bit of PowerShell. They keep having these status meetings, right? And the software developer, the engineer who's kind of in charge of this, keeps listing his statuses of stuff, and he keeps leaving off the buffering. And Ken keeps saying, dude, where's buffering? Like, we've got to have buffering. The guy finally comes back, he says, look, it's going to be really hard. It's going to take 6 weeks. Ken's like, oh my God, like we're already behind. We're behind schedule already, and you're telling me this is going to take 6 weeks. Oh, geez. I don't know. Goes and talks to Snover and says, yeah, I mean, he's telling me this is going to take 6 weeks. And Snover's like, that's BS. goes off and writes minus out buffer in 13 lines of code. So this parameter that probably nobody uses was written by Jeffrey Snover. It's still in the product, and it only took 13 lines of code. So I just think that's a really cool story. And there is use for this stuff. Like if you are doing implicit remoting and you've got a lot of objects moving around, you can use out buffer to batch these things so it doesn't pound the network quite so hard. It becomes more bursty and less of a continual stream of fire hose. I think it's pretty cool. There's another thing that actually did happen in PowerShell, although not quite the way anybody thought it would, and not for the reasons most people think it did. If you go back to PowerShell version 1 and a little bit in version 2, we had this idea of Minishells. And originally they were going to be called admin shells. And a Minishell, you only really saw it used once. Anybody remember the first SQL Server PowerShell support? That thing had a Minishell. And what that means is it's the PowerShell engine and one or more predefined snap-ins that all load as a set, and you can't load anything else into it. It's like locked down to just that bit of functionality. Now, these were originally designed as a way of counteracting the Windows architecture team's objections to the way .NET worked. So you got to go all the way back. Like we're talking like just after Windows 2000. We're talking Windows 2003. The Windows architecture guys hated .NET. They hated it. They hated the way it did versioning in particular. Their problem was that if you rolled something out and it had a lot of underlying dependencies, .NET didn't do a great job of helping you figure out if you had the right ones or not. It was a little bit of a mess. And they wanted stable software. That's all they cared about, was stability and robustness. And they just didn't see .NET. Well, they had made the decision to write PowerShell in .NET, so they had to find a way to make these guys okay. And they said, look, instead of relying on dependencies, we'll just bundle everything up. It'll all be together, and it won't have any dependencies. So that'll take care of the versioning problem. They said, okay, fine. So PowerShell engines plus a bunch of snap-ins, it's a standalone admin shell. The other reason it was kind of pitched, and this is why the SQL Server team bought off on it, was as a tech support mechanism. So let's say you've got a copy of PowerShell open. You've got 50 different snap-ins and 500 modules loaded, and one of your SQL Server commands isn't working. Well, the easiest way for the SQL Server team to troubleshoot that is to say, okay, unload everything else. Let's see if we've got a conflict going on. Except they know you. They know you're not actually going to unload everything else. So what they would say instead is, well, open up our mini shell, because we know the only code in there is our code. And if you're having a problem there, then it's our bug. But if it works in the mini shell, it's your problem. None of this landed well at all. For those of you who were with PowerShell back then, we hated mini shells. We hated the idea that there was this separate PowerShell for everything. Like you were going to have an Exchange shell and a SQL shell and none of them would be able to share across each other. Like defeated the whole point of the product. So it actually came down to a bit of an internet screaming match that I was involved in too, unfortunately, not proud. We're trying to tell the SQL Server team, this sucks, this is no good, this is not the way we use PowerShell. And Jeffrey finally, yeah, it was technically my idea, don't blame them, it was a bad idea, sorry, and we moved on. Technically, you can still make mini shells in PowerShell. You can technically still do those things. They only work with snap-ins though. And most people aren't writing snap-ins anymore, they're writing modules. So this is a thing that's in there, but it's kind of in our past. And importantly, you can't do this on PowerShell core. So cross-platform PowerShell doesn't have these things. Transactions. This is a fun story. Again, Windows PowerShell only, because we're going back in the day. Windows itself, as an operating system, has had a transactional file system capability and a transactional registry capability for a long, long time. Here's what that means. In a transaction, you declare the start of a transaction, and then you take several different actions, and then you say, okay, I'm done. And the computer agrees that either all of those things will happen or none of them will happen. Think of it like going to the bank. right? You have a check somebody wrote, you deposit it at the bank. The bank has to do two things. They have to go get the money out of someone else's account and put it in your account. That's two separate things that have to occur, but you need them both to occur, right? Like if they take the money, but it doesn't go anywhere, then someone's going to be upset. Or if they put the money in your account, but it doesn't come out of the other one, then the bank's going to be upset. So it's a transaction. They're said to be atomic, meaning they all happen together or nothing happens. Well, you can do that with the file system. You can say, hey, start a transaction. I want you to delete a bunch of files, copy these files over here, create a file here and change that file. That's the end. Go make sure either all of them happen or none of them happen. You can do it in the registry too. So the PowerShell team invested a ton of engineering making this work, right? Keep in mind, how do we access the file system in the registry? We do it through a provider. So the providers had to be built to deal with this. And then all the different commands, all the item commands, get child item, new item, move item, copy item, remove item, blah, blah. All those had to be updated to deal with transactions. So they did all this. They put it all in place. Lee Holmes, who was partly responsible for designing some of these things, says transactions were the thud heard round the world. No one cared. They never got used. A ton of engineering, great idea, just didn't fit the way we worked. Wasn't solving a problem that us administrators had. Bit of trivia though. There is one important thing that you probably use lots and lots and lots that relies on these transactions, and that's the Microsoft installer technology. It's like the only thing that really uses these. That's why if you get an installer that craps out in the middle, you'll get that whole progress bar as it rolls back. And that's what it's doing, is rolling back the transactions because it needs everything or nothing to happen. So again, I just think that's kind of a fun, cute little story. Hey, by the way, I am going to unlock chat. So if anybody wants to pop a question in the chat window, feel free to do that. You can send it to me directly, or you can send it to everyone, and I'll try and keep an eye on this, and we can maybe answer some questions for you as we go. Workflow. Anybody, I don't know if you should see a little reaction button down on the bottom of your screen if you want to do a little hand raise icon. Anybody worked with workflow? For those of you who've got your video, I'm seeing heads going back and forth. No, never worked with it. So here's the story with workflow. If you go back and read the Monad Manifesto, and there's an annotated version on it on the DevOps Collective's LeanPub account, so you can get it for free. Jeffrey laid out 4 things that he felt this new generation shell would eventually need to do. One was a composable command line, which is what we got in version 1 of PowerShell. 2 was basically remoting, which we got in version 2 of PowerShell. Number 3 was basically workflow, long-running tasks that could be interrupted, picked back up, and resumed. And look, at the time, customers were screaming about workflow. We want workflow. We want runbook automation. That's basically what workflow is. We need this type of thing. Well, it turns out they didn't. It turns out what they really just wanted was automation, and PowerShell had always done that. But the team put a lot of effort into designing workflow. Lee Holmes in particular, but put a ton of work into a great design. Then a sad thing happened. .NET Framework comes out with Windows Workflow Foundation. And in the Windows operating system, common engineering criteria, which is kind of a set of requirements that you have to follow if you're building code for Windows, they said you have to use .NET Framework when it does what you need. Now, the reality is most of the product teams were looking at that common engineering criteria and going, nah, I'm not doing that, that's garbage. But PowerShell itself was one of the common engineering criterion. And so Snover's like, geez, I mean, we can't just blow off the CEC because like we're benefiting from it. It's going to look really bad if we do this. So he came down and told the team, like, you've got a great design, but we're going to use WWF instead. We're going to use Windows Workflow Foundation instead. Well, here's what Snover had to say about it. Actually, this is what Lee had to say about it. People were demanding workflow. They love workflow diagrams. WWF was a big new .NET framework feature. The CEC said we had to do it. So we did it. Man, did they engineer the heck out of it. This was the major headline feature for version 3. I actually remember they created a sneaky way to show the MVP's workflow before it got released to anyone else. They gathered us all into a room after MVP Summit and said, if you tell anyone about this, we will kill you. Do not do it. And so we had to preview this thing, and we're like, yeah, it's kind of cool. We had some feedback. I screwed up workflows, Jeffrey said. 100% my fault, and one of the things I still feel terrible about. He says if we had went with Lee's design, people would probably still be using workflow and cheering it on, but as it is, no one uses it. Part of the problem is that when you write workflow in PowerShell, it looks like you're just writing a PowerShell function. It's got the same kind of language. Under the hood, that gets translated into the real workflow language. And that's the problem, is it looks like PowerShell, but it's not. It behaves differently. Variable scope operates differently. But like, you can get some parallel things going on, but apart from that, it was a lot of effort to not really get a huge benefit. So it's kind of one of those things that just fell flat. Yeah, Marvin, inline script hell. And the only way we could make everything work was basically to wrap it in an inline script, which means it wasn't workflow anymore. So like, why didn't you just write a function to begin with? So Josh asked, do transactions still work today? Yeah, on Windows they do. Transactions do not exist in PowerShell core, so cross-platform, but Windows PowerShell, they're still there. They still work. They work in the file system provider, and they work in the registry provider. The file system provider is a little goofy about it. Like, I would experiment a bit before you really committed something mission critical. But the registry provider, they're clean. That's what the -use transaction switch is. So you basically run start transaction, and then you get item, move item, remove item, copy item, whatever. And as you do all those things, you specify use transaction. And then you commit transaction. It's not commit, I forget the verb, or you can roll back. You can say cancel transaction, and it'll undo them, all those things. So yeah, and workflow is still in Windows PowerShell. It's just nobody uses it. And here's the irony of it. Microsoft kind of figured out that Windows Workflow Foundation wasn't that great. They deprecated it. Like, they've stepped away from it completely. So it's like, oh, geez, you made us do this thing. It sucked. Now you admit that it sucks, and we're screwed. It might be complete transaction at all. That's possible. It's been a long time since I messed with that stuff. This is a good one. This is a great idea that never happened. This is not in the product. The idea, and this was another Lee Holmes idea because he's the security guy, right? The idea was that as you created data structures in PowerShell, so we know that PowerShell commands all produce objects, and an object is just a data structure. Well, one of the things that PowerShell would add to an object was a tainted flag. And the idea is, if data comes from an untrustworthy source, you mark it as tainted so that other commands further down can realize. Oh, I'll give you a great example. Let's say you have a command called invoke web request, right? We have that. You invoke a web request, you get back a web page as an object, and then you pipe it to invoke command. Right? Terrible idea, because you just got random stuff from the internet and you're asking it to now run it. Well, with the tainted data idea, the idea is you would mark that, and a command like invoke expression or invoke command could look and say, no, what you just sent me is tainted. I'm not running it. I'm going to throw a warning or an error or something else, but that's not trustworthy. I'm not doing it. Sadly, it turned out to not clear the bar in terms of, you only got so much time and so many resources, and you got to get this thing out. And it didn't float high enough on the feature list to ever get written. But it's still kind of a cool idea. Like, it's an idea that persists in a lot of different data handling situations. You even see it on files, right? If you download a file through your browser or as an email attachment, it gets marked as unsafe, potentially unsafe. It's from the internet, and you have to unflag it if you want to do stuff with it. Same idea. That idea persists but it was going to be much broader and kind of built into the very base of PowerShell. So I thought that was pretty neat. Data streams. Oh, this is kind of cool. You're going to have to imagine it for a second. In fact, if you've got a piece of paper and a pen in front of you, I want you to draw me a little diagram. All right. So we all know that PowerShell has 6 data streams. You've got the success pipeline, warning, error, verbose, debug, and now informational. So you've got 6 pipelines. These are non-cyclical, right? So if you draw like 3 little boxes in a row, those are your commands and they're in a pipeline, and execution proceeds from number 1 to number 2 to number 3. That's it, nice and simple. The original idea, though, was that you would be able to create new data streams on the fly. You would be able to direct objects to whichever data stream you wanted. You would be able to bifurcate or split a stream. You'd be able to merge streams. So think like this starts to get really interesting in what you can do. You can produce an object, and if it meets certain criteria, it goes off to pipeline A. If it doesn't, it goes off to pipeline B instead of just being discarded, which is what where object does. And you process both of those pipelines in parallel. And they had an idea that it would be cyclical, meaning maybe the things that go into pipeline A are good objects, and the ones in pipeline B need some work done. And so you can cycle back. You can do whatever you need to them and then circle them back around and try again. And maybe now they'll make it off to pipeline A. Jim Truer was really deeply involved with this. And his idea is that this would make it so much easier and more powerful to write hosting applications that would host the PowerShell engine. Well, sadly, the developer who was really working on a lot of this only understood 3 streams: standard in, standard out, and standard error, which is what command line shells since the beginning of time have relied on. And they could not get this fully through his head. So they had all this design in place, and Snover was really clear, like, I want you to build this thing so that it doesn't assume it's in a command line. Like, it will be a lot of the times, but don't assume that, right? They turned around for a second, they looked away, and by the time they came back, this guy had hard-coded everything to assume it was a command line. And they're like, oh my God. And the amount of work it would have taken to roll that back and start over was too much. They would have missed their shipping deadline. Keep in mind, PowerShell version 1, its main customer was Exchange Server 2007. They had to ship PowerShell because no way was Exchange Server going to be held up. Like, that was the moneymaker back then. So we never got data streams. Fantastic idea. Like, if you draw the diagram of objects going off in different directions and then looping back and reprocessing and stuff, like, amazingly powerful, but it didn't happen. So, oh well. There's a bunch more. There's so many just like really cool stories of why things are the way they are in PowerShell. And a lot of the times it's, yeah, we forgot, or we messed that up, or we ran out of time, or we had this really big vision and we never got to finish it. So there's only the beginnings of it in there now. So much of what you see in PowerShell today is still building on pre-2006 ideas. Version 1 of PowerShell was planned for years. In fact, I want to go back to my first slide. This book cover is a children's book called Kermit the Hermit. Before there was PowerShell, there was Kermit. And Kermit, because it's a hermit crab and hermit crabs have a shell, Kermit was the code name for a project to port the Bash shell to Windows, to enable Intel to start using Windows-based machines instead of RISC-based machines to design Intel's chips. That was the genesis of what created budget and staff and team and everything else for what eventually became Monad, which was released as PowerShell. So this planning process was years in the making. Contrast that with version 2 of PowerShell, which had a 6-week design cycle, like very, very fast. It was actually a little bit less than that, very, very fast. So there's all this stuff at the basis of PowerShell that is kind of still in there and we're still building on. Understanding where all that came from, even the bits that didn't make it, really opens up an understanding. David, how many people were on the PowerShell team and what was the org structure like? Was it a dedicated team or a combination of different teams? It was a single team. The PowerShell version 1 team was probably 3-4 dozen people. And at the time, you would have a program manager who kind of architected things and kept it running. And then you had engineers who coded it. And back then you had testers. That was actually the biggest limitation in Microsoft, is that in order for code to ship, it had to clear test, and you only had so many testing resources. So you could only write enough code that could get through test. Everything over that was just basically wasted. If it didn't get through test, it wasn't going to go. So they would break them down into sub-teams. For example, Bruce Payette, as most of you know, was very in charge of the language design. The guy who wrote the parser worked with Bruce to actually parse what you type. Fun story. The guy who wrote the parser had no idea, had never used a shell, had no idea what PowerShell was supposed to be for, and wasn't fully like cognizant of what he was supposed to be doing. It's one of the reasons the parser got rewritten a couple times. But yeah, so it was a pretty small, fast team for Microsoft at the time. If you'd like to learn more of those stories, I would deeply appreciate your support on Shell of an Idea. It has been about 8 months in the making. It's been a ton of interviews with people who don't even work at Microsoft anymore that I've been able to track down. A ton of talks with Jeffrey Snover, some fantastic stories. And I think you'll enjoy it. So I do want to take some questions. So like throw them in here. I'm gonna let you unmute yourselves if you want to ask, but if we get lurkers, then I'm gonna shut that back down and we'll use chat. So Mike asks, how much of an impact did it have when people like Bruce leave? Why did he leave? You know, it's always an impact when someone who's had such a profound effect, because Bruce not only designed the language, he also was really the one who designed desired state configuration, the first go of that. So he's had an enormously outsized impact on the product. But when you work for a giant corporation like Microsoft for half your adult life, you can definitely get a little burned out, and you come to a point where it's just, I want to do something different, and I want to work for someone different. I just need a change. That's why Ken Hansen left Microsoft. That's why Angel Cavalos left. You had a lot of that original old guard that was just ready to move on. Blows my mind how PowerShell Commandlets are considered .NET classes. PowerShell Commandlets are .NET. Like, they have to inherit, they are a class. You write them in C# typically, and they inherit from a base class that defines what a commandlet looks like. And when you run a commandlet, PowerShell is instantiating that class and running a specific method. So it's got 3 methods: begin, process, and end. Kind of like an advanced function. In fact, the advanced function structure comes directly from the commandlet structure. What was adoption like internally at Microsoft? Did it catch on like wildfire? Yeah, I mean, wildfire can be pretty destructive and burn unevenly. So it was a little bit like wildfire in that regard. It took a long time. There's people at Microsoft, and there always have been, with strong Unix backgrounds. And they really get it, and they want to use a shell, and so they do. But you have a lot of people at Microsoft, especially back then, who were very much about the GUI. Like one of the comments, as the team and Snover are running around inside the company building support, one of the comments was, "What the F don't you understand about Windows?" And like, there was a lot of resistance. The whole history portion of this book. So the book starts with a history portion. There's a whole part about the different design decisions, including some of PowerShell's greatest misses. There's a section about the impact it had, the community that developed around it. There was a lot of PowerShell's history where it almost didn't happen, like where it was nearly killed and was on life support. Snover and those early team members really made a lot of potentially career damaging moves to keep it going, and they were They were in it. They were passionate. They knew they had something, but Microsoft at the time was just not it. Even Bill Gates, Snover was recalling a story. He said, I was talking to Bill, and Bill said, man, this is going to let us leapfrog Linux. We're going to kill the competition. This is so much better. Bill Gates got it, but the company still almost managed to kill it. A lot of teams were just absolutely not. And it's funny, I'll give you a little bit of that history. PowerShell version 1, they wanted to ship in Windows, and the Windows architecture team wasn't having it. They managed to keep it out. Brian Valentine specifically refused to accept the design change request that would have put PowerShell in. So PowerShell needed a new customer, and they went to the Exchange team, and the Exchange team at the time was being led by a guy who is literally the reason Snover is at Microsoft. He'll say, I didn't take a job at Microsoft. I took a job to work with this guy. And he said, Jeffrey, we know we need to scale. Like this whole Hotmail acquisition and the migration to Windows showed us very clearly that we need to scale better, and that means automation. My team is working on automating Exchange. Maybe they should be using that thing you're working on instead of doing their own thing. And he created that connection. And that's why Exchange Server 2007 was PowerShell's new customer. They were a great customer. They pushed the team really hard, and PowerShell team did everything they could to make the Exchange team successful. It was a great partnership. And it's the only reason I think PowerShell exists today. So we have that to thank for the Exchange team. I heard the Exchange team wrote a middle layer between PowerShell and Exchange so that they could rip PowerShell out if it didn't work. That's kind of accurate. What had happened was the Exchange team had already started off on their own direction. So they built this whole API level, and that made it very easy for them to just wrap PowerShell around those APIs. They could have wrapped anything. They hadn't gotten any further than that. So it all happened at a good time. Back in 2012 at TechEd, I asked how you can run a script without running my server out of memory. You said it wasn't a programming language. What would you say it is now? I would still say that PowerShell is not a programming language. It is a shell scripting language. Just like Bash, it's loosely typed. It's designed for the problem it is intended to solve, which is gluing together a bunch of disparate systems. PowerShell was always meant to be a little loosey-goosey, a little fast and furious, a little get her done, not as formal, not as structured. It's branched out. It solves a lot more use cases today, but at its heart, I still think it's a shell. Do you think Azure would be a thing without PowerShell and a real shell? Yeah, I mean, Azure was going to happen no matter what, and they'd have figured something out. I mean, you've got Mark Russinovich in charge of the thing, right? He's not a dumb dude. If PowerShell never existed, Azure would still be here. But I will tell you, one of the PMs in the Exchange team said to Snover, PowerShell is the reason Microsoft is in the cloud. Because before we had Azure, Microsoft's first big cloud product was Exchange Online. And the only way Exchange Online was able to be successful was because they had already made that investment in PowerShell so that they could scale their administration. So that showed Microsoft that there was some stuff in the cloud, and they went for it. Mark who? Which team was the last to adopt PowerShell? System Center. System Center still never fully adopted PowerShell. I'm pretty sure of the major product, like if we're talking major server products, it would have to be System Center. Oh, good question about DSC. I didn't see anything new about PowerShell DSC other than what we're seeing in Azure Automation and Azure Policy. I have the slightest idea. Couldn't tell you. I have been disconnected from the current state of the technology probably since version 6 shipped. I'll be honest, like having taken a senior leadership role in my company, I'm out of the day-to-day tech. I can't do the granularity. This shell of an idea in a lot of ways is kind of my last chance to keep my hand in and kind of my swan song. It's something I wanted to do for the community because PowerShell has just changed people's careers so much, and it's enabled so many of us to do so much that I wanted that history to be there for the community to go back and look at it. I didn't want these stories to die. And as I saw those original team members moving on from Microsoft, retiring in some cases, I knew these stories were at risk and we would lose them. And so that's why I wanted to do it. But this will probably be my last PowerShell project. Any chance the original better workflow might ever see the light of day? Nah, I doubt it. There's just better ways to do what that alleged to do. So look, I'm going to hit stop on the recording. We can keep going, but I want it for the folks who are here live, you're going to get something that the folks on the recording aren't. So let me hit stop. Boop.